Hello, everyone, and thank you for joining us for today's LuxpowerTek webinar, Basic Troubleshooting and Working Modes. Just a few quick items before we get going today. During the webinar, all attendees will be muted for best audio quality. If you have any questions throughout the presentation, feel free to use the Q&A button at the bottom of your screen to type in your questions. Those will be monitored. This webinar will be recorded and shared with all of you within a few days. And it is my pleasure to introduce today's presenter, Andy Daniels. Andy is the head of LuxpowerTek South Africa, bringing 8 years of expertise in the solar and energy storage industries. Based in South Africa, he also serves as technical manager, overseeing business development and service operations across South Africa and other English-speaking markets. So without further ado, I will pass it over to Andy to get us started. Thanks for joining us, Andy.
It's my pleasure as usual, Tatum, and thank you very much for the invitation. And to all of you out there, I greet you all. Welcome to another session with, I'd like to say it's a tech talk with Luxpower. I'm your host, Andy. And today we specifically going to be going through, as Tatum said, we're going to do some basic troubleshooting, and we're also going to look at some subtopics within that heading. So without further ado, let's get going. Right, so I'm not sure how many of you have joined in the previous webinars, but like Tatum says, they are available on Charge Solar's YouTube channel, and the recordings are available on request. So if there's anything that you need, please feel free to reach out to them. And then also we do have, like Tatum said, we've got a Q&A session. I'm hoping that we do have people available today to answer the questions, and then you can just follow the prompt at the bottom of the screen to ask your questions, and I'll do my best at the end of the session to answer any questions that you may have. And if I don't have the answer myself, then we'll get the feedback to you. All right, so today we're going to, our topic, today's content covers three subsections. So we're going to be looking at the installation troubleshooting, working modes, and then obviously the error codes. Now, at this point, we're going to assume that a lot of you are already avid and experienced Luxpower installers. So some of the stuff might be a little bit basic to you, but just bear with me because we're going to be going through some really sort of, I wouldn't call it mundane, but they're important things to ensure that the installation goes without any problems. All right, so the first sort of question that comes up here is the inverter won't turn on. Right, so obviously there can be a number of causes. So before we go any further into what the possible causes could be, I want to talk to you about what the process is in the manufacturing procedure at LuxpowerTek. I've been lucky enough to be in the factory on a number of occasions. I've seen how the machines are built. So I know exactly what happens when they are assembled. So all of the boards are picked in, they call it pick and place. So all the components in the boards are picked and placed by CNC. So they from there they are obviously soldered in place, and then they are checked. And some of the boards, even before they are assembled in the main machine, they have a point-to-point check. So in other words, where the boards physically go onto a test bench, and there are 2 points that are connected on there, and they're looking for certain feedback before it goes into the assembly. So once the assembly is done, the machines are completely assembled, and as they come off the assembly line, there is a test machine that, or a unit or a tester that will plug the contacts onto the machine, and it's computer driven. It runs a basic test, so it's either pass or fail. If it passes, it will go off to the aging section. If it fails, obviously it gets set one side, and then they have to look at it again and see what the problem is. In the aging section, it's a temperature controlled and sort of like an environmental room where they can lower the temperature to the extreme low, or they can raise the temperature to the extreme highest. And inside this chamber, they will put machines back to back, and one machine will discharge will receive solar and battery and discharge. And the output power will go into the machine on the back end as the input power, and they run that for 2 hours, and then they switch roles. So by the time you receive a machine out of the box, it hasn't simply just come off the production line with a wish. It's actually it's gone through some rigorous testing, and it's only then when it passes the environmental, or well, but the you understand the sort of environmental condition testing, does it get passed, and it gets boxed. And also when the machines are packaged, as many of you have unboxed them, you'll see that they're very well plastic wrapped. They come in foam packaging, which is shaped foam packaging, and most of the components that are in the manual that it tells you will be inside the box, and all of those things are checked. They're quality checked for to make sure that it meets the standard. So if you get a machine that doesn't start out of the box, how can that be? Well, we've got to consider that machines travel a very long distance from Shenzhen. Sometimes they'll ship out of Hong Kong. Then it's the shipping all the way to Canada. It might get offloaded in a dock. I don't know where your main port is, and then maybe on a rail, and then on the ferry. And by the time it gets to Charge Solar, it's had some travel experience, and it could be something that's wiggled loose. We don't really know, and I'm not making any excuses for it. But ideally, it's very, very rare that you get a machine that comes out of the box that's a failure. If you do, you obviously report it right back to Charge Solar, and they'll sort it out for you. Okay, so let's look at the possible causes. If you power on a machine, what could possibly be the problem? How do we troubleshoot this? Obviously, you're going to be using a multimeter to confirm that the battery and the PV and the grid is within the operating range. So the battery's got to be within the range of, I think, 46 volts right up to 56 volts. PV, make sure that the solar power that comes in is within the open circuit voltage power. Obviously, you can't measure current because there's no current flowing, but just make sure that, especially on the battery and on the PV, make sure that the polarity is correct. Positive to positive, negative to negative. Right, and then obviously from the grid, Canada uses split phasing, so you've got your live 1 and live 2, or hot 1, hot 2, and neutral. Just make sure that you've connected the right line to the right point on the inverter, and that's quite important. And then obviously just check that all the AC and DC breakers are turned on. And we've already had it. We've had instances where we've had DC breaker or breaker failure out of the box. So it's obviously it helps to check your supply at the top end of the breaker and at the bottom end of the breaker when the circuit is closed. All right, and then so you just verify the power up sequence is followed correctly. Turn on the battery system firstly, then turn on the built-in battery breaker. Make sure that the PV voltage of the strings are higher than 140. Why do we say that? Because 140 volts is the start voltage that we need to engage the relay, to engage the PV relay. So it's got to be higher than 140. All right, then you turn on the built-in load breaker, and then just make sure that steps one and two above perform properly. I also in the past I would have liked to encourage installers you can power the machine on with AC. And the reason I like doing that is because when you do that, you're given a chance to set the battery, in other words, to set the battery type. Because previously, like in our very, very first iterations of machines, we wanted to prevent an inrush of DC current, if you powered the machine on by battery only. But since then, we've obviously changed our logic, so you can power it on with battery. And then once the battery's powering on correctly, PV's on correctly, and AC's on, then you can go into the setup and you can change the battery configuration. In other words, you confirm the battery manufacturer, and like for instance Lithium, and who the manufacturer is, and then you obviously make sure that the battery communication is correct. Right, so let's go to the next one. Right, if you have no EPS output, what is EPS? EPS stands for emergency power supply, or it's basically just the AC out. So the possible causes are the battery can't discharge, or it's incorrect EPS setting. But let's go to the first point, the first part of that sentence. Sometimes if you have the battery connected, right, but you haven't chosen the right battery manufacturer, in other words, there's no battery communication, even though the machine powers on with battery, it will not engage the EPS relay simply because it's a fault in the chain that you haven't rectified. If you've chosen lithium as your battery type, then you have to nominate the correct battery brand. and also make sure that the cable that you're using, the communication cable between the battery, master battery, and the inverter is the correct cable. Our machines primarily only run on, well, they run on battery communication is CAN bus, the CAN bus protocol. So our pinouts are pin 4 and 5 for CAN high and CAN low. So depending on the battery manufacturer that you have, you're going to supply, you're going to have a battery cable that is exactly to that one. I think in the next slide, we're going to get to that. Right, so then just obviously, once you've made sure that the battery is correct, then you're going to just make sure that the EPS setting is correct, right? And we're going to do that in a second. But the physical thing that you can do is just ensure that the load breaker is switched on. Okay, the battery can't discharge or the incorrect EPS setting is the same heading, the troubleshooting steps. So check if the power backup function, which is this one that is highlighted in red block here, make sure that that is enabled. Why? If you are doing this in live maintenance, if ever you want to know what the switch does, simply just hover your mouse or your cursor, hover your cursor over the blue question mark, wherever it is, and it will tell you what the function of that setting is. So power backup, if you enable it, it then means that it will have power output on the EPS when there is grid. But if it's disabled, there will be no power out. You won't have any output there. In other words, it won't engage the relay. So the most important thing is to make sure that the power backup switch is enabled. Seamless EPS switching, I'll just mention these while we at it. Seamless EPS switching, it just means that we have two speeds of switching. We have a 10 millisecond switch and a 20 millisecond switch. And the only difference between that is the range of the incoming voltage from the grid. So if you want to know what it is, I'm not sure for the North American setting, but it will be for that narrower range, it will be the slower setting, and for the wider range, it will be a little bit faster. So you can basically just choose that for seamless. PV grid on or PV grid off. If you enable that, basically what happens is that if you have no battery connected, but you want PV, you want an output on your EPS while you have PV connected, then you can enable that. But just be mindful of the fact that the reactive power of, or the reaction time, I should say, of PV power is a lot slower than what we get from battery, okay? So for instance, if you have 5 kilowatts of PV on the roof and you have no battery and there's no grid, and you enable that button, basically what it'll do is that as long as there's PV, it will put out power on the EPS switch, on the EPS outlet, but the reaction time of that power to a load, for instance, if you might power on a drill or any type of load that has a high inrush current, then the PV might not be able to keep up with it. It's great for lighting and for running basic loads, but loads that require quick starting, it might not cope with that. All right, and then the EPS voltage, this is your EPS voltage that you set for the output voltage. Now, remember that our inverters or any hybrid inverter has got what's called a grid following voltage. In other words, as long as it's connected to the grid, the output voltage on the load breaker will always mirror what the grid is doing. So if the grid voltage goes up or goes down within a certain range on voltage and on frequency, the inverter will copy exactly what the grid is doing, right? It's only when it goes into off-grid mode or pure off-grid, then it'll go to this voltage that you set. Where's my mouse? It'll go to the voltage that you've set here. Right. Troubleshooting steps. Verify that the battery discharge is allowed. So in other words, if you go to the main screen, you can see below the battery icon, you'll be able to see this here. Now, this information that we see here is information that we get from the BMS. LuxPower does not generate this information by itself. Any data that you see displayed here is data that we get from the BMS. In this particular example, the BMS charge limit is 378 amps. So invariably there might be 3 100 amp hour batteries there, or it could be one 300 amp hour battery, like the LuxPower the PowerGen Max, which is a 16 kilowatt hour battery, but we use 315 amp hour cells in them, right? And then the discharge limit here will tell you what the battery is, or your battery pack is capable of discharging at any given time. This tells you that the BMS is saying that I'm open to being charged, or I'm open to being discharged. Force discharging is off. And here in this case, you can see that the number of batteries in parallel are 6, and the battery capacity is 630 amp hours. So this immediately tells me that these batteries are 0.5 C. Okay, it's a 630 amp hour battery pack, but well, it's a little bit more than 0.5 C, but you can see that these batteries are for max continuous discharge. They can only do, oh, hang on, sorry, I'm looking at the wrong thing, 504 amp hours. The charge limit is 0.5 C, the discharge is slightly higher, probably 0.75. Right, so you can set these here. Let me just move this out of the way. You can set your off-grid and on-grid discharge limits here. Now, what is the difference? So your off-grid charge cutoff and your off-grid cutoff SOC and your on-grid cutoff SOC, they will differ. The on-grid cutoff SOC is when your system is grid connected, but you're utilizing the battery during the day to supplement your loads. You will set that value to the lower limit where you want the inverter to stop using the battery, and then maybe take all its power from PV, or not from PV, but from PV and grid. And then the off-grid typically should be set lower than the on-grid. And that's in case you have, so let's make the assumption that the on-grid cutoff is set at 30% SOC as we have here, and the off-grid is set to 20. So if the grid should fail, let's just say, for instance, the grid is on and it uses battery power and the grid stays on. When it gets to 29% SOC, it will stop using the battery and it will then continue using grid and PV. And when the PV is sufficient, it will start charging the battery. And when the battery SOC gets to this value plus 10%, where's my mouse disappearing to? This value plus 10%, then it'll start charging the battery again. If the grid should fail, it will ignore this value, the 30%, and it will go down to 20%. That's the cutoff. Now, these values, especially the off-grid cutoff, that is determined by your battery manufacturer, okay? Some battery manufacturers will allow you to go down to 5%, some recommend 10, some 15, whatever the case may be. But this is ideally the lower limit that your battery can sustain in an off-grid situation. The on-grid is where you can set it for wherever you want to, or whatever suits your client's particular need. Right. Wi-Fi dongle connection. This is a really, I wouldn't say it's a common problem, but it's quite a daunting problem because nothing can fluster anyone like tech. And especially when it comes to trying to connect a dongle to the Wi-Fi. Now, we manufacture, or we sell our machines with a number of different types of dongles. The earlier iterations of our dongle was with a serial number that began with a BA, Bravo Alpha, and those dongles only worked on the TCP protocol, right? Then the newer ones are ones that will start with a DG, Delta Golf, and those are TCP and Bluetooth. And then I see even later than that, I see some models with BH. So we have the standard dongles, then we have the eWi-Fi dongles, and now our most recent releases are the dongles that can operate on the Wi-Fi 6 bandwidth, as well as 2.4G, 5G, Wi-Fi 6, and they are working on what is Elon Musk's thing called Starlink. They can connect to Starlink as well. Right, so it was a free plug for Mr. Musk. Right, so if we have a look here, we have on the dongle, you have 3 LEDs, right? When you plug the dongle in, the bottom one will go solid and the middle one will flash. And that basically means that the dongle is ready to be connected, or it's ready to be paired. Right, and then once you follow the dongle connection protocol, It's quite simple. I really, really like the new Bluetooth dongles because they are so easy to connect, and they connect very, very quickly, very fast. It's our older dongles. You plug them in. You had to go on your mobile phone. You had to look for the dongle SSID on your scan for Wi-Fi, identify the dongle SSID, connect to it, then keep the connection, then go to the app. And in the app, you had to be logged out, right? So always log out of the app first before you do any Wi-Fi dongle connections. So you log out of the app. With the older ones, you had to scan for the SSID, connect to the dongle, keep the connection, go back to the app, and there's a dongle connect button. You click it, and then the dongle would, your phone screen would automatically become the screen, a display screen for the dongle, and it'll show you which Wi-Fi's it could see in the area. You connect, you select the one, and then you had to key in the password. The newer ones, which work with Bluetooth, it's a slightly different operation. You still log out of the app. You still scan. Then you press the dongle connect. You make sure that your mobile phone is connected to the Wi-Fi that you want to connect to. So in other words, the Wi-Fi that you want to connect the dongle to, make sure that your phone is paired with that Wi-Fi. Then you're going to click the dongle connect button, and it'll give you two options. Do you want to do a TCP connection, or do you want to do a Bluetooth? You say, I want to do Bluetooth. Obviously, Bluetooth must be enabled on your phone. And then it will scan for Bluetooth devices in the area, and it'll pick up the dongle. You select the dongle off the list, and then it will automatically go to the set page. It'll populate the SSID, and then all you have to do is you have to put in the password. If it doesn't put in the SSID, you can key the SSID in on your mobile phone. Just tap on that section and type it in. Make sure you get the spelling correct. Do the password, and then click set with Bluetooth. And that setting or that setup is very, very quick. Nathan, I'm going to draw your attention to this particular slide here. And for your viewers, you'll see that these, the dongle connection guides, there are two down the bottom here. These are interactive buttons. When you do get this presentation or this slide pack from Tatum, these are interactive buttons. You can actually click on them, and it'll take you to the printed document. All of the settings that I'm talking to you about, they are available inside the box. Each dongle comes in a little white box, and inside the box is a paper. It's a sort of a paper insert that's folded up with all of the instructions there on how to do the settings. All right, so if you've lost a hotspot connection, troubleshooting, if the hotspot is disconnected automatically, please check if you have enabled a feature similar to the WLAN assistant, which will switch the mobile network because the hotspots don't have the internet. This is a little bit, it's very, very rare that you get something like this. And basically what it's talking about here is that there might be certain protocols that you need to set on your end, on the client's end, to make sure that you can get a good connection. But this one here particularly talks about the hotspot of the dongles, and I was not being able to see the SSID. I always recommend customers not to fiddle in this section because the dongles come pre-programmed, and the format is pretty easy to follow. Sometimes we have customers, or we've had in the past where customers, they know what the IP address of the dongle is, so they go into there, they get into the settings, and they change. They enable or disable a few encryptions and things like that, and it messes everything up. Charge Solar, I know, will be given the tool to reflash dongles. So if ever you have dongles that are not working or that have inadvertently been reset to factory or something like that, then you can always get them back to Charge. They will have a J-Link tool to flash dongles to reflash them with the firmware. And from time to time, we do also ship out new versions of firmware. So, for instance, you can there might be some, like for instance, when you pair your machine with a LuxPower battery, then you are able to see additional information on your monitoring screen purely by using the right type of dongle. We do also do LAN dongles. We do the ordinary dongles that we're talking about here. We do the LAN dongles, which are hardwired, but those we don't ship those with machines. You have to order them specifically. And we also have 4G and 5G dongles. In other words, dongles with a SIM card that you can order, and you can use that if you don't have the facility that you particularly need. Right, so just confirm that the network connected to the phone has been switched, or the eWi-Fi dongle hotspot has disappeared due to the restart of the dongle. All right, so our new app, I do know that our new mobile app has a lot more interactivity between end user or installer and dongles. Like you can reset the dongle, you can flash dongle firmware. I think you can request password resets. So, but we'll get into that in another training session next year, possibly. All right, so now we're going to be talking about the lithium battery communication. Once again, here is an interactive button on the right-hand side of the slide. All right, so let's look at the possible causes. It could be incorrect battery settings. We covered this a little bit earlier. If you have, I'm going to use an example, battery brand A, and you've selected battery brand C. The communication is obviously going to fail. Highly likely that it'll fail, and in that case, it's not going to put out any EPS output, right? So check that the battery is in the LuxpowerTek battery compatible list, and this list here is the list. I'm not going to click on it because it's going to jump out of the presentation. But this list, when you get it, Tatum, you can save this as well and keep it handy in your knowledge base. So if ever customers call you and ask you, "Hey, does this battery work or that battery work?" It's something that you can quickly access the list, have a look. It'll tell you which batteries our inverters work with, number one. It'll tell you which protocol to select on the battery list. In other words, when you're hard programming on the machine screen, or if you're using your mobile app or the web app, it'll tell you which number to choose. In other words, battery number 6 or battery number 8. It'll also tell you what the pinout configurations are for the batteries, and it will tell you which machines in particular we've tested those batteries with. And the list is extensive. It's quite a long list. Some of the batteries on there you might not recognize because the list is universal. It's for countries all around the world. So obviously some batteries take preference in certain countries over others. Right, check the battery brand settings match the actual battery brand. Verify that the communication cable is connected to the correct port. That's also a very important thing. So our battery in our machine, the RS485, not RS485, the RJ45 jack is screen printed on the side. It's screen printed BATCOM. So that's where the battery communication goes in there. And then obviously to the battery, you're going to go to the CAN. We don't use, on the list, it'll show you that we mostly or only use CAN communication. So that is where you should be plugging it into. I do know that on our pinouts, our pinout 1 on the BATCOM is RS485A, and the pin 2 is RS485B. And then obviously pin 4 and 5 is CAN, right? Check that the dip switch settings on the battery is set correctly. This is very important, especially if you're using multiple batteries where you have a master and a number of subordinate batteries. You've got to make sure that the dip switch settings are according to the manufacturer's recommendations. And obviously they differ from manufacturer to manufacturer. LuxPower has simplified theirs where dip switches are no longer used on our batteries. We do have them available, but from Lux to Lux, no dip switch settings are required, and it's been simplified like that. Then inspect the pin order of the connectors at both ends of the communication cable. So what they're talking about here is they're talking about the RJ45 plug. You will have your Cat5 or Cat6 cable with the plugs on either end. Just turn them over so that the brass pins are facing up, and you hold them next to each other like this, and you should be able to read the same color combination from left to right on both. And typically the standard, I think a universal standard is orange, white, orange, green, white, blue, blue, white, green, brown, white, brown, right? Some cables, even cables that we supply, if your battery does come with a BATCOM cable, you will notice that we only use the two wires that are required, and that's the CAN high and the CAN low. On the one end, we'll use that. Okay, inspect the pin order, make sure that they're both the same. And then some batteries can set different inverter protocols. Make sure that the correct inverter protocol is selected. What are we talking about here? I know in South Africa, there's a battery like Shotto, for instance. Shotto has to physically program the battery to talk to LuxPower or to talk to other battery brands. So just make sure from your battery supplier that it is compatible with LuxPower. And once you're over this hurdle, you're good to go, especially with a battery communication. Right, so here we're going to be talking about the wrong grid or load power reading or monitoring. Possible causes, you could have the incorrect grid wiring or CT related. So right in the beginning, remember we said that because this is a split phase, you have hot one and hot two, or live one, live two, and then you have a common neutral. Make sure that you have the live one and live two in the correct port, right? Don't switch them around. And then at the same time, also make sure that the CTs that you get are clamped on the right incoming. We mark our CTs. Our CTs are marked CT1 and CT2. That's obviously for live one or hot one and hot two. Make sure that they are connected correctly. And also, you will notice on the CT that there's an arrow here. There's an arrow on the CT, and those arrows should be pointing in the direction of the flow of current, right? So the current flowing from grid to the machine, the arrow points in that direction. Okay, so check that CT, ensure that they're clamped around the wire correctly, and that the arrow is pointing towards the inverter. What happens if you have one of your technicians, they do an installation, and the panel is quite cluttered with wires, and he's really got to get his hand in there and find the hot, and he gets it clamped on, he clamps the other one on, and he inadvertently clamps the CTs on one, that he clamps them on in the wrong direction. Does he have to go back in there and turn them around? No, it's not necessary, because on our settings page, we have enabled we've included a section here. You can see CT direct and reverse. So the standard, when the machine is shipped, it's disabled. Okay, this is disabled. So that's in standard configuration. But if you have inadvertently clamped the CT on the hot one or hot two, but you've turned it the wrong way around, you can enable this feature, and it will then reverse the reading. So in other words, it knows it knows to do that. But I think in the split phase, I think that we have to. You can't have one in the opposite direction. They've got to be. So whoever does your installation, make sure that the arrows all point in the same direction at least. Okay, so incorrect grid wiring or CT related issue, troubleshooting steps. Check that the CT setting is correct on the monitoring. Now, the machine will be preset with a sample ratio of the CT that is included. So LuxPower does not manufacture CT. So CT clamps, it's a buyout for us. It's a component that we are supplied from an external supplier. And so depending on the type of machine that you're using and the CTs that we've included, we will pre-populate the CT sample ratio. So you can see here, this one is 1 in 3,000. In the drop-down menu, you can have a 1 in 1,000, and I'm not sure if there's another one there. So why do we give you different options? Imagine you're doing an installation where your CT cable run is longer than, let's say, 100 meters. And you want to have an accurate reading from down there. So then you might have to buy a different, you'll outsource your own CTs. And if the CT is a 1 in 1,000 sampling ratio, then you simply have to match that with the CT that you're using. That's very important, okay? The CT sampling ratio is correct by default, 1 in 3,000 for the LXP 12K and 1 in 1,000 for the LXP US 8 to 10K. So please don't play around with those unless, of course, you are changing the CT itself, and then you can match the sampling ratio according to the CT that you're using, right? And then we've already covered the CT direction that's reversed. Right, so let's have a look here if there's anything else on this. So measuring is CT. On this drop down here, you'll either have CT or you could have a power meter. Of our machines, like our Trip 20 comes with it only reads with a power meter, so you can select the power meter there, or you can retrofit a power meter instead of the CTs, and then you simply just choose that off the menu. CT offset ratio, what is that? Where's my mouse? CT offset ratio, what is this? CT offset ratio means that we cannot guarantee the accuracy of the CTs that our supplier gives us. So remember, we buy them in the thousands, right? So the CTs are deemed to be accurate within a certain tolerance level. So once you connect the CTs to your hot and your hot 1 and hot 2, and you power on your system, and you notice that the system is exporting a little bit of power, it could be 5 watts, 10 watts, 15 watts, whatever the case may be. You then take your clamp meter, you clamp the hot 1 or hot 2, and you verify that in fact the CT, if it says it's exporting power, that it is exporting power. And if that's the case, then it's obviously an error or a marginal error in the reading. Then you can offset the CT. So if for instance, if the CT is exporting, say, 100 watts, and you set this value to a negative 100 watts, it will then stop at it will prevent 100 watts from going out. The converse, however, is also true. If you have a CT that is accurate and it's on 0, and you want to trickle in a little bit of power, you can also set it to a negative value. I do that here in South Africa because we have in Cape Town, where we are, most of the homes and businesses that are here are fitted with prepaid electricity meters. And some of the meters are only they all are one directional, but you have to apply and purchase a bidirectional meter if you want to export to the grid. But some of the meter manufacturers, they have a very, very low tolerance for exporting power. So if the client's prepaid meter or electricity meter detects a leak current to the grid, it shuts the meter off and it cuts their power. So what we then do is we set a negative value here. I typically set it to about minus 20 watts. So it always brings in 20 watts from the grid, day and night. Sometimes customers complain. They say, I don't want to be paying for all their power. Well, you know what? It's 20 watts. Really, you can't even buy a beer with 1 day's worth of power. So live with it. It's either that or nuisance tripping. Right. So external CT, the positioning. So the place, what they mean here is the positioning. Where are the CTs positioned? Why do we give you that option? So we have two options there. One is grid to user, and the other one is inside the machine. Because sometimes you will do an installation where the panel is too far from where you've done your installation, and it's a trick to run the CTs all the way there. So what you do is you fit the CTs where the grid connection comes into the machine, you clamp them there, and you simply tell the machine that the CTs are now inside the machine. It's located right here instead of at the panel. That's the big difference. The drawback for that is that it cannot measure any power that is going to the non-essential side. So if you can imagine, if you've got power coming in from your utility and it goes down to some non-essential loads, then you tee off from there to the inverter and your EPS loads. If you put the CTs inside the inverter, it cannot measure this flow on your monitoring. Okay. The great thing about putting it above the mains breaker on the inside the panel is that the CTs on the monitoring will give you the data of all the power that's coming in from the utility, which goes to essential and the non-essential. So that's the cool thing about that. All right. Buzzbar PCS rating. So I'm not very sure about this one because we don't use this feature in South Africa, but I'm assuming that if you've got a buzzbar connected, then you're going to do the rating here, but I'm not going to elaborate on that because I will just be guessing. So let's move on before it gets dangerous. Right, working modes and troubleshooting. Don't laugh at me, Tatum. Working modes and troubleshooting. Right, so the possible cause of, let's have a look here, not working in self-consumption mode. All right, what are the possible causes? That you've got other working modes enabled, and it's not in the active time of self-consumption mode. And so the troubleshooting basically, so the screen that you're seeing here is our new user interface, right? You will only see this on the new user interface, especially on the web portal. And some of you, if you are still used to using the old user interface, you can, in the top right of the screen, there is a button where you can go to the old setting page. For the old guys that like, what does it say? It's difficult to teach an old dog new tricks, right? So for the old dogs, if you like using the old setting page, it is still available. But this one is pretty cool because it gives you an overview, a glance. Here you can see the active mode. You can see that the active mode is that it's got PV charge priority set between this time, and then it's got self-consumption mode from midnight until 5, and then again from what looks like 6 to midnight. All right, so remember that our clock runs from midnight to midnight, so from 0001 to 2359. So this is what you're seeing here. These two working modes here are now displayed in the active mode. What do they mean by having active modes overlapping? So for instance, if you are asking it to do other functions that are overlapping these times where the bars overlap here, then you're going to get a corruption of performance, right? So just make sure that the active mode is exactly the way it should be, the way you want it, right? Okay, that's basically explaining exactly what I've said. Right, so working mode settings, battery communication, no AC input power, troubleshooting. Right, so first of all, make sure that the AC charge settings are set correctly. So let's just have a look and see. So it's not working in AC charge mode. In other words, where the AC charge, it's not charging the battery the way you want it to, or in the times that you want. Right, let's have a look at step number one, the obvious. Make sure that battery AC charging is enabled. All right, and then you can also set the AC charge power. There's two ways of doing it. You can type in the number here, the numeric, and set it, or you can simply grab the slider and slide it up and down here, and you can watch the value change. Very important, guys. In the maintenance page, I know a lot of you know this already. When you open up the maintenance page, right in the top, there's a read button. You have to click that first, okay? Because the settings page will be unpopulated. And if you go into an unpopulated page without reading anything and you do a settings change, it's not going to do anything. You need to, by clicking the read button, what we're doing is you're pinging the inverter. So you send a ping from the server to the inverter and it says, hey, send me all your information. I want to see what your settings page looks like. So this inverter will then, via the dongle, dump all of the settings onto the server, and it'll allow you to see what the settings are. And then you can do the settings changes. The reason why we have a set button next to each value is because you have to click set and wait for the confirmation message to come up on the screen to say set successfully or operation failed or whatever the case may be. But it's very important that you do that, right? So here under the AC charge, you can set the AC charge on the drop-down menu. You can set it according to time. You can set it according to SOC. You can set it according to voltage. You can set it to SOC and time, SOC and voltage. Right, but why do we give you all of those options? Because it's quite simple. Some customers or installers want to set the charge, the AC charge, regardless of what the SOC is. So they're saying, hey, listen, between 8 and 10 in the evening, regardless of what the SOC is, I want you to charge my battery, right? Or it could say between 8 and 10 in the evening, if the SOC drops below, it is below 30, then you can start charging, and you also have to give it an end flag. So it's a start and an end flag. So these are the flags here, right? So we're going to say we want to start charging at the lower value and we want to stop charging at the higher value. And we give you the option to do those settings in voltage as well. Then we give you 3 time slots to set the time, the charge times, right? So T1, T2, T3. Some customers, believe it or not, they will set exactly the same times in all 3. It's not necessary. The reason why we give you 3 is because maybe where your installation is done, you have different time tariffs or tariff codes for the cost of electricity. So you want to be able to work around that. So you can set in low charge tariff times, you can set those in there. And that's what that is for, right? I realize I've only got 15 minutes left and I've got quite a few slides to get through, so I'm going to have to talk a little bit faster. Working mode settings, the battery communication, troubleshooting. Check if the battery SOC voltage is larger than the AC stop charge voltage, and if the battery allows the charge. Okay, so yeah, what do we mean here? So sometimes a customer will call you and he says, hey, my battery's only at 89% and it stopped charging. What's going on? You know what? We can get what we call here, we call it SOC drift. You will have a situation where it's very easy to look at it at a glance. You can see it's 89%, but when you look at the battery voltage is already at the capacity. So that basically means that the BMS reporting to the inverter is giving us the wrong SOC reading for the battery voltage. Or alternatively, it could be that the charge is not allowed or the discharge is not allowed. So that's why we give you all of this information here displayed so that you can you can pick it up from there. You can also pick it up on the data page simply by scrolling through all of the information on the data history. And we've seen it before. You can have SOC 90, battery voltage 49, SOC 90, battery voltage 54. Same system, same page. And that just shows us that the BMS communication from the battery is incorrect, inaccurate. Right, generator won't start. Okay, so what are the possible causes? The generator start conditions are not met, right? It's either that or the dry contact port is not connected or grid is on. Right, so let's start here with the generator start conditions not met. This particular description only applies to systems that have got generators installed that have got smart switching. In other words, generators with an auto start and stop button, which you've auto start and stop feature, which you've wired into the inverter via the dry contact port. Right, so the dry contact port is normally closed, common, and normally open. And depending on what type of switching your generator needs, you will use those. In the previous video, we discussed what you can put through them, what type of voltage and what type of current you can put through them, AC and DC. Okay, so now what we're going to do is in the generator settings section, you can determine, so this is only applying for auto start generators, right? So microgrid, what is that? If you enable microgrid, what it means is that the inverter now knows that there's no grid supply, but in fact there's a generator that supplies the site with power. And in that case, it will make sure that absolutely no power, no, not even 1 amp, is exported either via the AC input line or the generator line. Why? Because it's obviously dangerous for a generator. Right, so here you can choose your BMS charge current limitation. So this limitation here is obviously to set the charge current for the generator. Remember that when a generator is running, it has to take load and charge the batteries at the same time if there's not enough PV. So you want to make sure that your loads are taken care of first and that the charging is limited so that you don't overwhelm your generator, all right? So what they mean here is just make sure that the generator start and stop values are set correctly, as well as the SOC. Remember that with the SOC and the voltage, the SOC, the trigger voltage has to be the lowest value that you set -1. So in other words, if you set it at 20 to start, when the value gets to 19, it will close or open it'll send the signal to the generator to start. Then there will be a warm-up sequence. Then the generator will run, the relay will open, and the generator relay will only open if the voltage and frequency output of the generator criteria are met. So if it's over voltage or over frequency, then it won't open. So remember that if you have a generator, this is why we have a warm-up sequence. So make sure that you leave enough space in your battery cutoff SOC to counter that. That's the one thing. And if you have a very old generator, a nice trick to do is to put another load on the generator, a smaller load, so that the voltage regulator can bring the voltage and the current within frequency within parameters. Okay. Right. Possible causes: the generator start conditions are not met, the dry contact port. So here's where we have the dry contact port. Yeah, there's the generator dry contact port. And as you can see, it's simply just this is actually the connecting port. Here's the dry contact port here. So you can see that we've got normally open, common, and normally closed. So you can see that when the generator is switched off, this is normally closed. This switch is closed. And when it needs the generator to start, then this will open and this will close, right? So depending on what type of starting trigger your generator start feature needs, you will wire it accordingly. And here's the single line diagram on how to wire it up, right? Make sure that the generator support make sure the generator supports starting with a dry contact port, and make sure that there's no grid power. Otherwise, the generator won't start. So what do we mean by that? Our inverter cannot take power sources from two different places, all right? So it's either AC in or generator in. You can't run both at the same time. Or you can, but only one relay will open at a time, all right? AC coupling, right? Let's have a look here. AC coupling is not working. The possible cause for that is the start conditions are not met, and the grid sellback is disabled. So for this, right there, it's obviously a two-part thing. The start conditions are not met. What do we mean by that? So here we have the start SOC of the battery and the end SOC of the battery, right? So the the AC coupling feature will only work when this is correct, and also that if grid sellback is disabled, then the AC coupling won't work either. So just make sure that you cover those, and then we should be working. Right, check if the AC coupling start conditions are met. AC couple will only start when the battery is discharged below the AC coupling start voltage. And another cool feature about our inverter is it obviously can trigger voltage on that AC coupling port, which is the gen port, so that it can, for grid-tied inverters, for AC coupling, sorry, it can trigger inverters to start and to stop by simply shifting the frequency. Right, AC coupling not working, AC coupled start conditions not met. Okay, so we've done this already. Make sure that they enable the grid cell back function and set the grid cell back power larger than 0. The AC coupling will not work if the grid cell back power is disabled when the grid is on. Right, so this is, we've done this one. Right, troubleshooting for typical errors. Fault errors. Look, these errors are largely, I'm not going to go through all of them in detail, but they are largely, they will give you a very, very good description, not on the machine itself, but in the troubleshooting in the manual itself. And I will make sure that Mona sends Tatum the fault and the error codes for the machines that are sold in Canada. I'm sure you guys have that already. So it basically just tells you if it's a fault, what is causing the fault, how to clear the fault, and if it still persists, then send it in for repairs. Right, so the MX3 failure. So basically, we have in this machine we have 3 microchips. You can see them there. Right? And this is where we write our programming to. And sometimes we have failure either between the connecting ribbons between the machines, or there could be an incorrect firmware or a bug on one of the software, and then that needs to be recovered. But the recovery process is very well documented in the user manual. Now here, this one just gives you an example, right? For an error 00 M3 Rx failure, you just re-update and restart. And if the error occurred during the update, then check the firmware update had been done correctly. So what it means here is that sometimes we have where you're running an update and the update is interrupted. It could be either interrupted by a break in communication, like with the Wi-Fi, or the files, not all of the files download successfully, and then you've simply got to do it over again. And it could be as simple as just rerunning the update, or it might require a hardwired update. In other words, where you have to do it from a laptop via cable. All right. Okay. Now, like I said, I'm not going to go through all of these because they really, really mundane. They're very self-explanatory, and all of them they pretty well described what causes them and how to fix them. And there are some really cool ones like this where the PV isolation is low, where the insulation resistance detection on the PV cabling is triggered, and it, for your own protection or for the protection of the installation, it will give you this warning. So it basically tells you what to go out to do. So you're going to go out and measure the line to make sure that the insulation on the string hasn't been compromised. And typically, we find this when we have cables running over a sharp edge, and with weather they rub and they fray through the insulation of the cable. Then we will have a leak current to earth, and then we will get PV isolation low on our machines. And then obviously you're going to measure the lines to see which ones are affected. And the other thing here is also that on the maintenance page, you can actually enable and disable this feature. It chips enabled, but you can disable it. All right, so now we're into the Q&A section. Tatum, you can come on with your mic and let me know if there are any questions in the chat group. I did get a message from Joe. I just want to see what Joe says.
I don't see
Oh,
any questions in the Q&A. If
mhm.
anybody has any, please type those in now. Andy, thank you so much for joining us today, and thank you to everyone who attended this call as well. As a reminder, you will receive the recording of this webinar within a few days, and it will also be available on our YouTube channel. Also, just a reminder, this is the last webinar in our three-part LuxpowerTek webinar series. So if you missed the previous webinars on the app and web monitoring or the gen port and parallel configuration, you can find those on our YouTube channel as well.
Your microphone's off. You've muted your
Weird.
microphone. There
I
we
don't
go.
know how I managed to do that, but I just popped our YouTube channel into the
Yeah.
chat there. So that is where you'll be able to find all the recordings. And I still haven't seen any questions come through the Q&A, so I think you did a great job, Andy, again, as always.
Thank you very much. It's been my pleasure, my absolute pleasure. Yeah, so wishing you guys all the best for the remainder of this year. And once again, from LuxPower, thank you to each and every one of you for making the brand a success. Thank you for supporting Charge Solar in distributing our brand throughout Canada. Remember that I always like to use the phrase that at LuxPower, you get family, and that's exactly what we are. You know, we're just a call away. We're a instant message away. If reach out to Charge with all of your questions, Tatum will make sure that either Mona or Joe or myself gets it, and we will give you instant feedback. I'm not sure if you guys run like chat community groups where you can share information and things like that. They're very handy, and like Tatum says, there's a very handy YouTube channel with tutorials and things on there. So go mad, guys! Thank you very much for your support. Take care. And if I don't speak to you guys soon, have a fantastic Christmas.
You too, Andy. Thanks so much. Take care.
It's my pleasure. Go well. Goodbye.